So today we are going to start with first asymptotic notations. So asymptotic notations. First comes the big O notation. The big O. So big O notation. So fn, a function fn, a function. Okay, fn is said to be big O of Gn if there exists a natural number n naught such that natural number n naught and a positive constant c1 such that for all n greater than equal to n naught, fn is upper bounded by c1 into gn. So what this tells us is that suppose we have a plot like this of fn. Okay, suppose this is fn, any function, and we have a natural number n naught. Okay, so gn may be anyhow here, anyway in this part, we're not interested, but beyond n naught, c1 into gn should be asymptotically upper bounding fn. Okay, so it's greater than fn beyond n naught. So this is what is the big O notation so all about. Sorry in case you couldn't see, I think because of the camera. Okay, so a function fn is said to be big O of Gn if there exists a natural number n naught and a positive constant c1 such that for all n greater than n naught, fn is less than equal to c1 of Gn. So from the plot you can see that this is fn and this is c1 into gn. So c1 into gn beyond n naught is greater. Before n naught it might be greater, may not be greater, we're not interested. So there exists a natural number n naught and a positive constant c1 such that this happens, then we say that fn is big O of Gn. Okay, so this, and one more thing is that transitivity holds. Transitivity holds means if fn equal to order of Gn or big O of Gn, as we say it, we call it to be order of Gn also. Okay, so if fn is order of Gn and Gn is order of Hn, then we can write fn as order of Hn. Okay, so that's it. Now we go into big omega. So the big omega notation. Okay, so now we go into big omega. Okay, the big omega notation. So fn is function fn, okay, is said to be omega of Gn. Okay, said to be omega of Gn. That is the upper bound. So omega is actually will give us a lower bound. So lower bound on fn, it will give us a lower bound on the function fn. So fn is said to be omega of Gn if there exists a natural number I'm writing NO, natural number N naught, okay, natural number N naught, and a positive constant, let's write as C2 such that for all n greater than or equal to N naught, Fn is greater than or equal to lower bounded by C2 into Gn. So as you can guess from the above plot, this time the plot will be almost same, only our C2 into Gn will be below Fn, beyond N naught, right? So this is Fn and this is our C2 into Gn. Okay, so if this happens, we say that Fn is omega of Gn. So big omega, and we come into the theta notation. If both of these holds, we go into theta. So theta notation. Often we see in lectures theta notation is being used. Okay, so Fn is theta of Gn. Now you already know what this will be if there exists a natural number N naught and positive constants C1 and C2 such that for all n greater than equal to N naught, we have Fn as bounded from below and above. Okay, so Fn here. So what did we use? Let me just check what we did here. Fn was greater than C2Gn. Okay, so Fn is upper bounded with C1 into Gn and lower bounded with C2 into Gn. In that case, if both of these holds and there exist two constants C1 and C2 such that this happens, then we say that Fn is theta Gn. Okay, Fn is theta Gn when both big O, Fn is both big O of Gn and Fn is also big omega of Gn. If both these conditions happens, we say Fn is theta of Gn. So this is basically what we are saying, and we can draw the plot again and not. So this is Fn and this is our Gns. Okay, so this is Fn, it's upper bounded by C1 into Gn, lower bounded by C2 into Gn. These two are positive constants. This is a natural number and this happens beyond N naught, so we say it to be a theta of Gn. We also have transitive property holding all throughout, so theta of Fn if fn is theta gn and gn is theta hn, then fn is theta hn. Before also for omega also transitivity holds. So these are basically the three notations: the big O, the big omega, and the theta notations. So we'll again go to small o notations and the small omega notations. Basically we usually don't use those notations a lot, so let's do them later because we'll necessarily not use them. They are simple. So small o is basically similar to our big O. It's just fn is small o of gn if for all positive constants c there exists a n naught, such that for all n greater than n naught, fn is strictly less than c of gn, and vice versa, fn is small omega of gn if for all positive constants c there exists a n naught, such that for all n greater than n naught, fn is strictly greater than c into gn. So basically n naught is depending on c in that condition. So that is our small o and small omega notations, and those are usually not required. So we'll end our basic of asymptotic notations here. Thank you.